tension in data release.
Yeah, it's especially when there's so much competition nowadays for funding, and when you're funded to do something, and then it's really, really hard to then make it not only available to the general public, but then it's also available to other groups who also, who were not funded necessarily to generate this data, and then you're basically, using your money to then give the next group essentially free data. So there's, the one thing about the science world is there's a lot of sharing, but there's also a lot of, not to make it sound too bad or anything, but there is a tendency to be a little bit stingy when it comes to sharing data. And so probably more than 90% of scientists out there are more than willing to share things, because if you don't put it out there and you don't make this data available to everyone, then the next big discovery may never happen, because my area of expertise might be such that when I see this one data set, I can only make certain interpretations from it, but then you give it to another group and another set of eyes, and they see something completely different, and they might be able to do something different with that data. And then it's discoveries fuel new discoveries, which then fuel further discoveries.
Yeah, it works a little bit both ways. So what are people scared of for sharing their data? People are scared that someone else is going to publish it first and get more famous than you are. And sometimes that happens. But the life sciences have gotten much, much better about it. There's a recent example. So this guy at Stanford discovered or invented something really super cool. So what this guy figured out how to do is to take genes for light-sensitive ion channels and selectively put them in specific neurons in especially mice, because you can manipulate the genes of mice relatively easily, at least if that's what you do for a living. I don't.
Someone can do it.
Someone can do it. Well, in fact, you can't even, it used to be apparently 10 or 15 years ago, you would get funding to make a mouse model of some human disease. You can't do that anymore because it's, I don't want to say it's too easy, it's too standard. You can't get a grant anymore to develop a model of something. There are people there are factories basically that do that now.
Companies do.
Yeah, that's what I mean.
Say I want one.
Private companies that do it. Or often they'll give one. So that's one example of things getting given away, is when people make these transgenic animals, they'll often ship them to other labs for two reasons. One is because they have to, because NIH put it in their grant contract. And the other reason is because that's how they get famous, is by having their model become the standard model or the most important model. But anyway, this guy at Stanford figures out how to take these genes, put them in specific neurons, and manipulate them using laser light. And this is, for various reasons, going to completely revolutionize the field of what we do. It's not going to solve everything, but it's going a long way. And he was very clever about what he did, is he basically made it available to absolutely everyone. Said, here it is. And now he's becoming super, super famous. And
he's in a million publications.
Well, now he's had an enormous scientific impact, right? So if you're a scientist, what you want is scientific impact. And you can do that different ways. But definitely one of the ways you can do it is by making the most of what you have. And one of the ways to leverage what you have, sometimes in some circumstances at least, is to give it away. Because there may be many things you could do with it that you won't. Either because you don't know what to do, or because you just don't have enough time. Right? So if you have a really rich data set, and you really want to make the biggest splash with it, the best thing is to just throw it out there and let everybody paw over it. The same thing is true with tools. So he invented a tool that would have enabled his lab to do 1 billion new experiments nobody else could do. But it would have taken them 1 billion years to do 1 billion experiments, right? And if they throw it out there, they can still do some of them, and they get lots of credit, and also lots of real accomplishment. You hear this stuff about wanting to be famous. It's sort of that, but it's also really just wanting to have an impact. Everybody wants to do well enough to have a successful career. Most people actually don't really care if they're really famous. They just want to do well. They want to be successful and have an impact. But these questions about that are really interesting and evolving really fast. There's a lot of new pressure from the funding agencies, completely reasonably, to say if the federal government paid for your experiment, everything you do should be public? Seems kind of obvious, doesn't it? But it's not the case. For instance, right now, most of the publications that people write are in journals that members of the public can't read unless they pay thousands of dollars. That's ridiculous, right? I mean, why should it be that way? You're a taxpayer. You should be able to read the results of these things. So there's pressure on the publication side and on what will happen with the data. I mean, it can be a little silly if you say every elementary school student should be able to use this. Well, they're not going to. But, you know, there's an appropriate place. And keeping it just for some kind of priesthood of scientists is bad.
And also a lot of times with these publications, when they finally do make it to like the news or, you know, like Newsweek or the New York Times, a lot of times it's a summary of the actual work, and it gets to the point where it simplifies it to so much that it makes associations seem like they're causes. Like if you drink coffee, you'll have lower risk of cancer or something. But then if you actually read the actual study, you'll see that it's not a direct cause and effect, but it's more of an association between those who drink more coffee have lower incidences of cancer or things like that. And a lot of times, you know, if the public isn't able to access the primary article, then what they're being told is just, you know, they can't make a judgment for themselves, and it's just someone else telling them what to think, basically.
Have any of you ever done that? Have you ever read like a popular story and then gone and found the actual article? Even once? It's gotten easier actually, because a lot of the media now will actually link to the real article. That's become much more common in at least the more reputable parts of journalism. So if a report comes out and it's in Science or Nature or whatever, they'll often actually have a link that will take you, if not to the actual published article, because it may not be publicly accessible, but to usually those journals have a public version of the article that is much better than what's in the ordinary press. But that's the sort of thing, you know, you should do it sometime this year. Just something. Just pick something that you read about, I don't know, climate change, or something about what college students are like, or some study. You're always reading about a study, right? Go read it, right? Find out what it really is. Because, you know, otherwise you're not going to know. Another question.
Kind of on this topic, I was recently reading an article that said that because of like how research is structured, it's actually leading to like more non-ethical behaviors in when people do research, and I was wondering what you guys thought of that idea.
Research ethics. It's a very big topic.
Yeah, I mean, so it's a little hard for me to say whether I think it's getting worse or not, because I haven't been doing it that long. Yeah, I mean, I guess, so there are ethics and then there are ethics. So there are things that you absolutely cannot do, because if you're, what's his name, Dr. Wakefield, you're going to go to jail for basically lying about your, does everyone know who I'm talking about? I think I have his name right.
You better tell the story.
So this is actually a big deal for me, because I'm a neurologist, but although I'm not a pediatric neurologist. So this guy, Wakefield, about 10 or 15 years ago, publishes an article saying that he saw like 8 to 10 kids that got the MMR vaccine and then they became autistic.